It's time to study some properties of vectors in order to better understand how vectors behave. Property 1. Vector product is not commutative, unlike scalar product of two vectors. That is, if you have a bar and b bar as two vectors, then a bar cross b bar and b bar cross a bar are not equal to each other. Remember what we mean when we have equal vectors? They have the same magnitude and they have the same support as well. So those are equal vectors. So that a bar cross b bar and b bar cross a bar, why are they not equal to each other? Because they have the same support, they have the same magnitudes as well, of course. Then what is different? The sense of a bar cross b bar and b bar cross a bar are different, and since they are different, we say that they are not equal to each other. In fact, they are 180 degrees apart. If a bar cross b bar is going in one particular direction, say like this, then b bar cross a bar will be 180 degrees opposite to that. So it's going in this direction. So that is why you can write a bar cross b bar as equal to minus of b bar cross a bar, and vice versa. So you can also write b bar cross a bar equals minus of a bar cross b bar. If a bar, b bar are two vectors and m is a scalar quantity, then the position of m in the cross product between a bar and b bar makes no difference. M could be first multiplied by the vector a bar and then the cross product could be performed, or m could be multiplied by b bar and then the cross product a bar cross b bar could be performed, or m could be multiplied by the resultant of the vector a bar cross b bar. All of them would give the same result, the exact same vector. So it reads as m a bar cross b bar equals m times a bar cross b bar equals a bar cross m times b bar. If a bar and b bar are two vectors and m and n are scalars, then again the actual positions of the scalars m and n will not affect the cross product between the vectors a bar and b bar. This is a generalization of the second property that we went through. M a bar cross n b bar equals mn times a bar cross b bar equals m times a bar cross n b bar equals n times m a bar cross b bar. The fourth property is the property of distributivity over vector addition. So if you have three vectors a bar, b bar and c bar, the vectors b bar and c bar have been added. That is, we take the cross product of the vector a bar and the resultant of the vectors b bar and c bar. So that gives resultant of the vector a bar cross b bar and a bar cross c bar. A bar cross b bar plus c bar equals a bar cross b bar plus a bar cross c bar. This can also be written as b bar plus c bar cross a bar equals b bar cross a bar plus c bar cross a bar. Remember, the vectors given in 1 and 2 are not equal to each other because the order of multiplication of the vectors a bar with b bar plus c bar is different. In the left side of equation 1, you have a bar coming first and then b bar plus c bar, and in the left side of equation 2, we have b bar plus c bar coming first. So therefore, when you want to equate these two to each other, you would have to put a minus sign on either one or the other. So when you have the single vector a bar on the left side of b bar plus c bar, you call it left distributivity. And when the single vector a bar is on the right side of b bar plus c bar, It's called right distributivity. Of course, the vector a bar could also be expressed as a resultant of two or more other vectors. Like for example, we could have d bar plus f bar cross b bar plus c bar. The same rules would apply. So a bar then could be expanded further, and then you could use the right distributivity to evaluate a bar cross b bar, and similarly a bar cross c bar, and so on. So the property of distributivity is very important when the sum or the difference of vectors is used along with cross product. And this is something which we encounter many times while doing problems in mathematics and physics, and therefore it is important to know it.